You'll recall that the first equation here is one of the two basic equations. It just expresses the fact that the acceleration multiplied by the time interval gives us the change in velocity, which when added to the initial gives us the final velocity. The second equation is more complex, having been derived from this equation and the other, the two most fundamental equations, but it's still one of our four fundamental equations of uniformly accelerated motion, and we should be very familiar with it by now. Combining the fact that acceleration is net force divided by mass, F standing for net force here, we didn't really write that down, but we got to understand that is the net force. We're going to substitute this in for acceleration, and of course we're going to obtain these two equations where the acceleration here and here has been replaced by F over m. Then, recall, we've already done this, of course. If we isolate the F delta S, which we've learned to identify with work, and up here analogously isolate the F delta T, we're going to obtain two equations. And these are the two equations we obtain. And these are simple rearrangements of the two equations we have here. And we've already seen that F delta S is understood to be work, and that's going to be the change in the kinetic energy, the 1/2 mvf squared minus 1/2 mv naught squared, the final minus the initial kinetic energy. And this is again our work energy theorem that says that the work done by the net force equals the change in kinetic energy. Here we have F delta T equals mvf minus mv naught. We know that mv is momentum, so that mvf and mv naught are final and initial momentum. So that this F delta T, whatever it is our change in momentum. Looking over here, we simply extend these ideas, or we rewrite these equations. So we have this F delta T, again this is net force, times delta T, is final minus initial momentum or change in momentum. We're going to call this F delta T the impulse of a force. So we have impulse equals change of momentum. Here we see that F delta S is just our delta W, the work done by the net force. Again, F is the net force. And the work done by the net force is the difference between the kinetic energies, or the change in kinetic energy. So we have the work energy theorem and the impulse momentum theorem.